All right, we have a bug. It's another bug problem. Traveling along the coordinate plane, its position is described by these two equations. The x-coordinate is 3t plus 2, and the y-coordinate is 4t minus 1. So at any time t, plug in time, we can calculate an x and y coordinate and figure where this bug is. So let's go ahead and do that. Let's see, for time 0, that's pretty easy. The bug is at 0 plus 2 and 0 minus 1. When time is 1, let's see, 3 times 1 is 3, plus 2 is 5, and 4 times 1 is 4, minus 1 is 3. See, for 2, we've got 6, 8, 8, 7. For 3, we've got 9, 11. And we have 3, 12, 11. Oh, look at that. You notice how we're going 2, 5, we're going up by 3, so the next one's going to be 14. Over here, we're going up by 4, so the next one's going to be 15. Okay. Let's go ahead and plot some of these points. We have 2, negative 1. 2, negative 1. Let's see, 5, 3, 1, 2, 3, 4, 5, 1, 2, 3. And notice it's over 3, up 4, so over 3, up 1, 2, 3, 4. That should be 8, 7, and then over 3, up 1, 2, 3, 4. That should be 11, 11, and look, it looks like it's right. We'll stop there because I'm about to run into my equations again. Let's connect these with a nice line. Okay. Now, I am going to make the line go in both directions because technically, these parametric equations, time can go negative and the line goes forever in both directions. Even though I suppose our bug doesn't travel infinitely in both directions. So one thing we're asked is how fast is this bug traveling? Well, we're told that the bug is traveling, I guess in the original problem, 5 units per second. And how do we calculate that? Well, from one point to the next, on this here, from the lattice point, I guess, to the next, we're traveling over 3 and up 4, and we should know this by now, 3, 4, Pythagorean theorem is going to give us 5. So this bug travels, and this is from time equals, let's see, 1, right here, to time equals 2, right here. So the bug travels 5 units in 1 second. That's 5 units per second speed. 5 units per second. Now, the second thing is, what if I wanted to speed this bug up so that it was traveling further every second, right? Say twice as far per second. Well, not too hard to do. I just want the bug to travel from, say, t equals, I call this t equals 1 if I want. Let's actually, I want to travel from t equals 0. I want to travel from this point right here all the way up to here, so twice as far in the same amount of time. All right, so I want to travel over here and up here in the same amount of time. So I just want to move. I want to skip. I want to kind of skip over this here. I want to call this. All right, there's our time equals 0. I want to go from. Pause. I'm just going to have to go back and cut all that out. It's a lot of nothing. Except I will not leave it in. Okay. The bug travels from t equals 1 to t equals 2. That's a 1 second journey and travels 5 units in that 1 second. So 5 units per second. If I want to speed the bug up, then I want to have it travel twice as far in the same amount of time. So these points are all going to stay here, right? But we're going to put in a new, all right, we'll call this, I don't know, our new time here. Okay. We'll still call this 0, but I don't want it to reach this point right here. Right? I don't want it to reach that point in 1 second. I want it to reach that point in half a second. So let's put 0.5 there. And then I'm going to put 1 here. Then I'm going to put 1.5. And we'll put 2. Right? So now the bug reaches places that it originally reached in 1 second. It takes a half a second to get there. So it's going twice as fast. Now we have to figure out what our new equations are. Well, before our time, so our time increases by 1 from here to here. And on the x-axis, time goes, let's see, it goes up 6. And on the y-axis, it goes up 8. So, and that makes sense because we've moved from our new time, right, from here to here, we move over 6, and we move up 8 every second, every new second now. So our new equations are x equals new rate of change for x, which is 6t, or 6 and then times t, and then plus our same old starting point, plus 2. And y equals new rate of change for y, 8t, minus 1. If you want to check it out, you can go ahead and, you got the table right there, but you can make the new table, and you could plot the new points, label the new times, and you should see that the line is going to look exactly like this, except time 0 will be here, and this, instead of being time 2, will now be time equals 1. The bug went twice as far in the same amount of time, it's going twice as fast.